Hello, everyone. My name is Anwesha. I'm a third year BSc Physics with Particle Physics and Cosmology student at the University of Birmingham. I'm here today to talk to you about how or why to be a physicist. I'm really excited to be here, and I hope you're all doing well, especially in this pandemic that's been going on for quite a while now. I really wish I could be there in person to talk to you, but given the situation, it's best for everything to be online as much as possible. I mean, even as of now, I'm actually in quarantine as I record this talk because I just got back from a red list country. So, without any further delay, let's get started, and I hope you enjoy the talk. So, I thought I'd start off by sharing a little more about me and where I'm from. I have lived in a lot of places, so I thought that would be a nice thing to share. I'm from the eastern part of India, from the state called Odisha, and I was born in a city called Rourkela, and this is one of the most famous monuments of the city. It's a statue of Lord Hanuman, and I remember visiting it every summer when I was a kid, when I used to go visit my grandmother. So lots of cheerful memories there. Although I was born there, we actually lived in Delhi, which is the capital of India, right about here, for quite a while, and then when I turned about 4.5, we moved to East Africa. We moved to Tanzania and we lived in Dar es Salaam, the commercial capital of Tanzania, for 13.5 years. And that has to be the best time of my life. It's the most beautiful city on the planet. And yeah, I mean, I could be very biased with that, but for me, it is the best place on the planet. And this is a view of one part of the skyline. Dar es Salaam is one of the fastest growing cities in Africa, so it was lovely being in such a fast developing city during my, I guess, developing years. So in this picture, you can also see the port right here. It is a coastal city. And actually, I don't think you can see it in this picture, but one of our apartments when I was in, I think, sixth grade, my family and I we used to live somewhere about this area, one of the buildings here, because I remember seeing this port and these two buildings out of my window. Then, after I completed 12th grade and graduated from high school, we moved to West Africa, this time to Ghana, and we lived in Accra for a little under a year. And Accra is a very nice city, very developing, it's a very developed city, and there's lots of potential for growth there, be it academic, research-wise, or even, financially. So definitely give it a visit if you're around the region, because it's one of the most promising cities of Africa. In fact, they actually also have an African Institute of Mathematical Sciences, which was founded by Dr. Neil Turok, and he is a world famous cosmologist. So, yeah, just thought I'd throw that in there. So, after we stayed in Accra for about a year, we moved back to India, but this time to the southern part of India. And this is the state of Karnataka, and the capital is Bangalore, which is where my family currently lives. And the picture of you see over here it shows a part of the skyline of Bangalore, one of my most favorite areas of the city. We live quite far from the city, so seeing buildings is buildings this tall is a rare sight for me back home. And then in 2019 September, I took a long flight and flew to Birmingham from Bangalore. And yeah, it has been a wonderful journey for me since I joined university, and I thought I'd share that with you. Just to move myself so you can see the main library. So this picture that you see here, I clicked this in first year of our main library. It is not just a beautiful building, it is very modern, lots of facilities, and very easily accessible. And I believe they also have some procedures in place if you would like to, use the services and resources that they have available. So do check out their website if you're interested. So that's plenty about me. Let's dive back into what this talk is actually going to be about. So here's the list of what I will talk about. How to make the most of your time in secondary school. Some of my experiences as a physics fanatic in school. I am not exaggerating. I was known as Space Girl by all the primary school students when I was in grade 10 through 12. Yeah, like if I walked down the primary school building, they'd just say Space Girl is here, and that's how I was known. I'm also going to talk a little more about life as an undergraduate physicist or researcher, and I'm going to share my experiences working on two research projects over the last year and currently during my summer 2021, I guess, in a pandemic. The project that I'm currently working on as a summer research student is called the Speculos Project, and I'm going to talk more about it in future slides. So I'm basically building a cloud detector for them. The other project that I have been working on for quite a while now, since late last year, is the NewsG project, where I'm helping them out with some simulations for a new type, or rather relatively new type of particle detector called a spherical proportional counter, which is going to be used for dark matter detection. So yeah, although I am a physicist, a lot of the tips I will share can actually be applied to any field of interest. So the tips I'll share are actually quite transferable. There will be some physics in the talk, but I'm going to do my best not to get too technical. So I thought I'd start off with a little bit of, like nostalgia, with sharing a picture of, excuse me, it's not COVID, I promise you. Yeah, of my beloved school, the Heaven of Peace Academy in Dar es Salaam, Tanzania. So my school was actually situated on a hilltop, so we could see the ocean from the windows, from the classroom windows. This is the admin building, and this was actually the senior school or science building. So we had all of our physics, chemistry, and biology labs in this building over here. And yeah, we also had a whole bunch of classrooms, and even the art room, I believe, was in this building. It is in this building, like right about there. The physics lab is this one, right? These windows that you see. So moving on to sharing some tips about how you could make the most of your time in high school. So I'll tell you a little bit more about my time in high school. So as you can probably tell by now, I did my high school in Tanzania, which is an LEDC, and it is still a developing nation. That means that a lot of the facilities that are available in the West for science outreach, such as, let's say, high-tech science museums, or like really developed universities which have dedicated outreach programs with lots of resources and facilities, that wasn't really available to me. And I was the kind of student and person that I always felt this urge that I want to do more. I have the interest, I have the passion, but I didn't always have that expert guidance that I sought. It's Yeah, I mean, my story, it started pretty much when I was about 5 years old, and we used to live in my dad's office compound, and there was a massive truck yard, and in the evening and this was in the outskirts of the city, so you could actually see the stars very clearly. I mean, you can see the stars pretty clearly from anywhere in Dar es Salaam because it's not very polluted. It's still, I mean, it's very scenic, and it is very raw, I would say, in its natural beauty. So, anyways, so yeah, we'd go out for walks in this massive truck yard in my dad's office compound, and I used to look up at the stars, really like be fascinated by the view of the stars, and I'd ask them a lot of questions, and they introduced me to the Childcraft series, and they gave me the book in the encyclopedia series called The Universe, and it's everything's history since then. Like, that was the first time I came across physics, astronomy, and learning more about the universe, and I was hooked. And since then, every single, I guess, academic step that I took it with the mindset that I'm going to be a physicist one day. I want to be a researcher one day, and what can I do now to help me achieve my goal? And today I'm going to be sharing with you some of the most, I guess, valuable lessons that I learned along the way. Step 1. Don't be afraid to ask for support. This is a little bit of a daunting task for many of us. I too was a little bit intimidated by, asking for support. It might make me come across as being, vulnerable or weak, or it might show that I'm not independent enough, but it's actually quite the contrary. Asking for support is one of the bravest things you can do, because that shows that you are fearless and you have that determination to take that extra mile forward that most people probably won't. So, while it might sound a little bit daunting, getting support for an activity or asking for support, let's say if you want to do more physics projects, ask your physics teacher in school that, hey, I really like physics and I'd like to do more. Have a chat, maybe hang out with them after school, see what the lab has to offer, or why don't you come up with your own idea for a project? I'll give you an example. I had a very wacky idea, or maybe not so wacky idea, when I was in senior school with my physics teacher. So when I was a kid, I had a remote controlled helicopter that my dad got from me when he came back from touring after some office trip abroad. He got me a remote controlled helicopter. I broke it the first time I used it. It was sad. Like I couldn't really control it as well because it was really windy, and it flew decently and then it crashed. And I think the gyroscope didn't work, so I couldn't really use it as well as a helicopter anymore, but I saw that a lot of the parts were not too damaged, like they were still working. So I kept that aside, forgot all about it until one day when I was in 10th grade. I was going through my old things in my room and I found that helicopter and I was like, yeah, maybe I could do something with it. So I took out the motor and I went to my physics teacher and I was like, I think I want to convert my helicopter into a boat. And I was so glad and thankful that I approached my physics teacher because he was very happy to hear that, and he encouraged me to come up with a plan and maybe, think about what sorts of problems might arise if I tried to convert a helicopter motor into a boat. That made me, really think about things as a scientist, as a researcher for one of the first times in a way. And the first thing that I had to think about was, how are we going to get it to be waterproof? What is the weight limit? Like, how much mass can the structure actually support with that motor? And how would I want to shape the boat if I was to, turn the helicopter into a boat, and so on. And I won't go into too much detail about that, but it wasn't a success. I was not able to turn my helicopter into a boat. But what I learned during the process about what it takes to be a scientist, that was the main achievement. And yeah, and all of the learning I had with that was because I asked my physics teacher for support. Second, look up outreach events happening near you. So email universities, institutes, science centers, museums. I know Birmingham has lots of universities, University of Birmingham being one of them, and we have some of the, I would say, most exciting research going on in the country. So do not be afraid to reach out to universities, institutes, and I don't think I've visited the Science Center here, but I have heard lots of good things about it, so do visit them, get some contacts, get engaged in their activities. I can give you an example of something that I did when I was in primary school, I think. Yeah, I think I was in 3rd grade. So we were very lucky to have a professor in a local university nearby called Dr. Jiwaji from the Open University of Dar es Salaam. And he has a passion for astronomy and outreach. And when I was in 3rd grade, that's when the school taught us about, the solar system, stars and planets and all for the first time. And they invited Dr. Jiwaji to come talk to the 3rd grade about, stars and the planets. And at the end of his talk, I was extremely nervous, but at the same time I was like, I know I want to know this person more because he's the first one I've heard in this city who has actually, talked to me about the stars and the planets that are not my parents and my teacher. So I went up to him and got his visiting card. And he was so excited that, that I was able to approach him and able to get his contact details, and we've been in touch ever since. In fact, he also helped me a lot with some outreach events that I did in high school, and he also had a very critical role to play in one of the other things that I'm going to talk about in my next slides. So I don't want to give any spoilers. So the reason I'm sharing this story, it's just that if you reach out to people, most of the time, from my experience, I would say even 90% of the time, to be fair, they're happy to reciprocate your interest and they will be happy to support you. So just take that step. Don't be afraid to be a leader. Yeah, I mean, to be fair, we live in the 21st century and the greatest advantage we have is the internet. And well, if we need support for outreach or if we need support for, academic development, if you look around in person and you can't find someone, you will definitely find legitimate and, proper verified sources online who will be able to support and encourage you. And let's say there's, no cool activities happening around you. Like if you live in a place that's relatively far from the city or that's not as developed in terms of the resources available to you or the facilities available to you. No big deal. Why don't you try something new on your own? Why don't you bring something cool to your place? And I do have a story to go with that as well. So this story goes back to when I was in 9th grade. I remember sitting in the computer lab during my lunch break doing some work, and then I think I was checking the news or something for some reason, and I stumbled across this website which mentioned that World Space Week was coming up. I'm pretty sure this was like either the 29th, 30th of September or something like that, because I saw it and I realized that, hey, this news is mentioning that World Space Week is coming up. World Space Week is from the 1st to the 4th of October. 4th to the 10th of October. And that's next week. And I just felt like, I felt really bad that I had not come across that before. And I searched up events if they were happening, if anything was happening in Dar es Salaam, Tanzania for World Space Week, and there was nothing going on. So I just immediately felt like this is terrible. I need to do something about this because it's really sad if World Space Week is an international celebration and no one around me knows about it. So I walked to the principal's office with like 10 minutes to spare in my lunch break, and I walked up to him and I was like, can we do something for World Space Week coming up next week? And he was quite happy to support it, although, I mean, he did mention that it would be nice if, if a bunch of students could get together to do it, because the principal is an extremely busy person and administration was also quite busy with it. So as soon as I got the go-ahead from the principal, me and my friends, we immediately, we got to action. So I didn't really have much time to plan it out, so everything was very spontaneous. So I came up with very simple activities in the first year that we did Space Week. So in 9th grade, when I first initiated Space Week, we just had a fact of the day and we had a question of the day. So if you answered the question of the day by the end of the week, all the answers after you submit your answers, and we'd mark all the answers, you would get rewards. So we'd give out house points in our school to anyone who does anything good, because we had 4 houses, and at the end of the year, the house that has the most points wins. So that's how it started out in 9th grade. By the time I got to 12th grade, so that's 2018, we had expanded our reaches so much. In addition to the fact of the day and the quiz of the day, we were able to hold astronomy contests in our school. We had stargazing nights. We had talks from various people, including Dr. Jiwaji, and one time we also got a researcher from the States who was in the country at the time to come give us a talk. He is a brother of one of my math teachers in high school. So yeah, it's kind of like a domino effect. And the best part was that after I graduated, the Space Week tradition actually continued in the school because a lot of students were interested in to continue Space Week. So they came up to me and they were like, "We want to continue Space Week after you graduate. How can we do that?" And that just filled my heart with so much joy to see that it was actually making an impact. And yeah, I mean, my highlight of high school has to be World Space Week from grade 9 to grade 12, and the reaction of the primary school students in particular. They're so full of creativity. Like some of for the arts contest that we had during Space Week, where you could create any art piece themed around space. We got pillow covers, we got nail art, like nail art as in not like nail art like for nails, but like they hammered some nails onto a wooden plank and then used thread to create, I think, like a galaxy pattern or a star pattern, something like that. We had we had like we had some cardboard 3D designs as well. We had paintings, we had poetry, we had cards. It was so lovely to see all that around. So yeah, that kind of and all of that outreach event was literally sparked by this one idea that I saw that there was nothing cool happening around me. So I was like, let's start something cool. And it, and like touch wood, it was a massive success thanks to my wonderful friends who really helped me out. And we made a fantastic team and the really supportive school administration and teaching staff. In conclusion, for that story, I guess, the moral in a way would be to be brave, step out of your comfort zone and experience new things. Even though it might not be second nature to you, it with time you will get more comfortable with it the more often you expose yourself to such like experiences. So yeah. Another point that I learned quite a bit, and this was especially during my time 11th grade, 12th grade, and university, especially university, I'd say talk to people. Building connections is really the key to accessing a lot of opportunities. So the more you talk to people who share similar interests with you, the more you learn about the field and the more you learn about opportunities. For instance, the two research internships or the two research projects that I'm doing right now in university, those weren't explicitly advertised positions. So if you looked up in the university website if you or if you email the career counselor in the department, they wouldn't know about those jobs or those positions, for instance. It was a lot of emailing around and asking around, hey, is there any cool project going on that I can get involved with? I can't tell you how many times I had emailed different people before these two projects worked out for me. So during my first year, I emailed so many people in the different research groups around the university, and they just didn't have the opportunity at that moment. And then, as they say, something when the time is right, it will click. And then in, I think, October or November 2020, I emailed a person a researcher in the gaseous detectors group at our university, and I was pleasantly surprised when they emailed me back the next day saying that they wanted to have a chat with me, like a meeting, and get to know more about me and my interests and what I could do with the project. It felt like a dream come true, to be fair, because I had nearly given up hope that anyone would respond to any of my emails. So yeah, perseverance, it helps a lot. Okie dokie. Moving on. In this slide and the next one, I'm going to share a little bit more about my experiences with summer schools when I was in high school. The first summer school that I attended was after I finished 10th grade. Now, how I found out about the summer school is a very interesting story of its own. And remember Dr. Jiwachi, who I met in 3rd grade after he gave a talk about the solar system and the stars? He had been in touch with me throughout the years, and I had also been in touch with him. Like, I guess it works both ways, of course. Yeah, so we'd been in touch since I was in 3rd grade, and he contacted my mom because I did not have a phone back then. I mean, or like I had a phone back then, but I didn't use it much, so no one could pretty much reach me on it. So he contacted my mom because she's also a university professor and mentioned to her that there's this professor researcher from Canada coming to Tanzania to set up an institute called the African Institute for Mathematical Sciences. And my mom told me about Dr. Jawaji's phone call, and I was super excited that yes, we absolutely have to go meet this researcher. And turns and I had no idea who this researcher, like I knew his name, but I didn't really know what he did. So the only time that we could meet up with him was the day he left, that the day that he was going to leave. And that was, we could literally only meet him at the airport. So yeah, we drove to the airport at 8 at night. He had already checked in and he was just like waiting, like he was in the waiting area, and we were allowed into the waiting area because, yeah. And while we were in the waiting area, we actually sat at a table for a good hour and a half, and then we couldn't recognize him. He was sitting at a table very close to us, and then after an hour and a half, we realized that is that the professor that we've been waiting for? Turns out it was. So yeah, we went up, we joined him at the table, had a very pleasant conversation with him. He was none other than Professor Neil Tirog, who is the founder of the ekpyrotic theory, or the cyclic theory of in cosmology, of the cyclic theory of the universe. So this theory basically states that the universe is actually not just, it's like a parallel, it's like a parallel universe theory. So you have it builds on the concept of brains, which comes from the word membrane, so remove the MEM. So you have a brain and you have another brain. Every time they collide, you have the Big Bang, and then the brains move apart. And each of those brains is a universe. So that's that theory in a nutshell. And it was while I was chatting with him, that he highly recommended that I apply to this summer school called the Perimeter Institute, called ISSYP, which is the International Summer School for Young Physicists. This was a very prestigious summer school, and they accepted students from all over the world. And this was the first time I had even considered going abroad during high school for exploring my interests in physics. So after meeting up with him, I decided to, start building my application to apply for the summer school, and I applied. To my surprise, I was accepted into the summer school, and I was overjoyed. And that following summer, I went to Canada. I went to Waterloo, to the Perimeter Institute. It is a breathtaking place. Just being around, so many like-minded people and so many like-minded students my age for the first time, it just overwhelmed me. I never, had been around so many people who share the same interests as me, and it finally felt like, I was understood from an academic or intellectual point of view, where I could talk to a teenager my fellow age about, cosmology, and they would understand me. They could get me. Like, it was like we were this was like a typical like conversation at summer school. Like, for instance, if we're having lunch together, one of my mentors and we were having lunch together, and he taught me about calculus and like derivatives while having dessert. And it was not just physics during the summer school. So of course we did have lots of lectures and activities and talks from distinguished researchers and professors during the summer school, but we also had lots of fun activities. We visited Niagara Falls. I think we also went for laser tag, or yeah, we had some activity. I can't remember. I'm pretty sure I went to laser tag at some point. So yeah, summer schools are a great way to like develop your interests, meet other like-minded students. And for me, what this summer school taught me was that I did not want to be a theoretical physicist. Now, the Perimeter Institute is a theoretical physics institute, And a lot of the tasks and activities that we had were to do with theoretical physics. So they were very mathematical and, like calculation centric. While I love math, I really do enjoy math. I do not want to do math all day. I would much rather, set up camp in the physics lab and just live there. I would so do that anytime. But doing math all day is not my jam. Like, I'll do math if it's to get an experiment done. So that's what this summer school helped me figure out. I do not want to be a theoretical physicist. So, what was next for me? I decided to check out another summer school, which promised to be a bit more experimental centric, and I applied to it. Now, before we move on to the next slide, I would like to point out if you want to apply for the International Summer School for Young Physicists, do check out this website and see what their application looks like now, because I attended it like 5 years ago, so things might have changed. So the next summer school that I applied to is called QCSIS, or the Quantum Cryptography School for Young Students, and this is at the Institute for Quantum Computing, again also in Waterloo, Canada. And this summer school was more focused on learning about quantum cryptography techniques, and it was more experimental centric. So we got to deal with a lot of interferometers, and also we did a lot of experiments with electron diffraction and so on. So I got a lot more lab experience with this, and that convinced me that yes, I am definitely an experimental person and I'd enjoy this far more. And to summarize that in a nutshell, I'd say, as I said before, summer school is a fantastic way to learn things that no school curriculum will ever teach you. You'll make friends from all over the world. You'll make lifelong friends as well. And you'll gain amazing mentors who will guide you through your career. And that was, my summer schools were the first time that I got those mentors in specialized fields that I really enjoyed. For instance, like one of my mentors, or I guess she was actually a lecturer in QCSIS. You can see her right here, Electra. We are in touch now as well. Like I can just message her and we catch up on what we've been up to, and it's fantastic to have that guide, that career guide in a way, who you can look up to, and she really inspires me. In fact, in this picture, actually, you can see me right here, that tiny face right there. So if you are interested in applying for QCSIS, I highly recommend it. And you can check out how to apply at this website right here. Moving on, I'll give you a super quick guide on how to apply to summer schools, or just any summer school. Like, this is a very generic guide. I'll keep this super quick. A lot of universities have summer schools within their department, so check out university websites. Later on in this talk, I will share some links for summer schools offered by the University of Birmingham. Track deadlines. This is super, super important. You do not want to miss applying to your favorite summer school just because you got the dates wrong. And do pay attention to the format of the dates. North America has a different format to the rest of the world, so be alert. Be prepared for answering essay-type questions, video-type answers, and maybe even an interview. So you could anticipate some common questions such as what drives you, or why is blah blah blah, blah 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 being the summer school a good fit for you. Take a demo interview with a friend or family member or teacher. Now, first thought in your head might be, I cannot talk to my friend and have a demo interview, or to a family friend, because it's going to be too awkward and they'll make me laugh. That's exactly why you should do it. If you can get over that awkwardness and keep yourself composed throughout that, you're going to nail that interview. Reference letters. So you would need to get reference letters from your physics or math teachers, most likely, if you're applying to a physics or math-based summer school, or from the relevant subjects teachers. Sometimes they even might ask for a reference letter from a teacher who's not that primary subject. So keep an eye out for that. And lastly, the most important point, stay resilient. It's not the easiest thing, but it's definitely possible. It's very, very possible. And eventually, even though you might have to face a lot of, difficult times before you get the reward, you will get there. So just stay resilient. And I think it's actually worth mentioning as well that I got rejected by 5 universities before I got accepted into Birmingham as my first choice, into my first choice degree as well, with a scholarship. So yeah, rejection can be really hard to deal with. It can be very demoralizing. It will make you question your worth at times. But the key thing to remember is that a rejection is not the thing that defines you. What defines you is how you get over that rejection and the self-confidence that you have. So hold on to that and stay resilient. It will take you places you've never imagined. If you asked me 5 years ago where I would be for university, I would never have said University of Birmingham. And right now, I can proudly say it's the best decision I ever took to come here to pursue my studies. I thought I'd share with you some more pictures about World Space Week. So I have already shared the story of World Space Week and how it went. So here's some pictures. So we had a telescope display. We put together so this was my telescope. It wasn't a very great telescope, but it was good for display and teaching people about the mechanism of how a telescope works. And this is a telescope that we had in school, but no one knew how to use it because the manual was in German and we couldn't translate it. Google Translate was not helpful at all because there were so many technical words. In this image over here, you can see a bunch of the art submissions that we received from the primary school students, and it just fills my heart with joy seeing this. This is the talk that the researcher from the States gave about satellite data for studying the weather and temperature patterns around the sub-Saharan Africa region. This is a picture of the stargazing session and the observation session that we had. This is Dr. Jiwaji, my first ever mentor in physics and astronomy. And this right here is me in 12th grade addressing the crowd. So if you're interested in more in World Space Week, I will share some links in the later slides on how you can get more involved with the Astronomy Society at the University of Birmingham, and we do have activities planned for World Space Week, so you can get involved. So now let's fast forward 4 years to where I am today. So this is the Physics West building on campus at the University of Birmingham, and you can see me right here hugging the placard. And yeah, I think this was last November. And this is the physics building at night, and that's Old Joe, our clock tower, our beloved clock tower on campus. So first I'm going to talk about my research project that I've been working with the gaseous detectors team at the University of Birmingham on. And this is basically for a dark matter detector. So we know that 68% of the universe is dark energy, 5% is ordinary matter, so like my phone, this coffee cup, this calculator, and me. Matter like that, just 5% of the universe. And 27% of the universe is dark matter. That's a significant chunk that we know very little about. A lot of projects are underway and ongoing to learn more on how we can detect dark matter and study it to know more about this elusive type of matter. So the NEWS-G project, or a spherical proportional counter detector, basically uses this principle shown in the image over here. So you have a light dark matter particle. So this is in particular a light dark matter particle. It collides into an atom or a molecule. There's some recoil. So that's like basically, if you're playing pool and if you take, I guess, the white ball collides into one of the other colored ones, the white one recoils a little bit, something like that. So this molecule over here, it recoils, and in that process, it actually releases one of its electrons. It liberates electrons. And yeah, you can have further chain reactions because those electrons will go and knock electrons off of other molecules. And that's what we call an avalanche in technical terms. And that is the basic principle. And as the avalanche can help generate a signal that can be detected by the detector. And with that, if you have a light dark matter particle, it interacts with that. And if you have an avalanche, that means that there is a light dark matter particle which passed through your detector. On this note, I'd actually like to make a shout out to my supervisor / mentor with the project that I've been working on with spherical proportional counters, to Yanis. And he has been extremely supportive, a very, very nice mentor and guide, and has been very patient in teaching me a lot of the new concepts and being patient with me as I goof up every now and then. So thank you, Yanis. Here I'm going to share a little bit more about the spherical proportional counter and exactly how it works. So, as the name suggests, it is spherical, right here. So, you have the sphere, and in the center, this bit is the actual detector. It is the sensor. So, if you have a light dark matter particle coming in, it reacts with the gas inside the sphere, it liberates electrons. The gas molecules, they recoil, and they can make their way back to the grounded shell. And the electron makes its way to the positively charged anode at the center, which is at a really high voltage. And these consecutively lead to the signal detected, the recoil and the electrons being, having the avalanche effect as they, liberate more electrons off of the molecule. So as I mentioned in the previous slide. So the basic principle of this is that opposite charges attract. So we know that electrons are negatively charged, hence they try to drift towards the anode, which is positively charged to a very high voltage. And that energetic colliding particles can knock electrons off of atoms or molecules. So the dark matter particle comes zooming in, it knocks an electron off of the gas, and that electron travels around. So here's a better, clearer picture of it. So this is a copper sphere, so a spherical proportional counter. Typically we have a copper sphere, and within that copper sphere we have a noble gas mixture or any other gas mixture. The key is it should be an unreactive gas. The reason why it should be an unreactive gas is so that you don't have so that the gas is not too reactive. For instance, if the gas is reactive and you have an electron zapping through the region, that's going to cause far more sparks and signals, and it could get very, very messy for us physicists. So use a noble gas or a very unreactive or stable gas mixture. So at the anode, as mentioned, this anode, you have the high voltage applied, and then you have a support rod over here, and that is grounded, so that's at 0 volts. And this is the signal readout channel, so you have all the wiring and everything that goes in here, and then you have the signal, and then you have all the post-processing occurring where you analyze the signal, analyze the noise, and so on. So the final setup for μ(g) or for the spherical proportional counter for dark matter detection, the main project, which is μ(g), is going to be set up at SNOLAB, which is the Sudbury Neutrino Observatory in Sudbury, Canada. And this is actually it's located in a mine. So the reason why this is underground, 2 kilometers underground, is so that the ground above it can act as a natural shield against cosmic rays. So that is the layout of what the lab is like, and μ(g), or the spherical proportional counter for μ(g), will be situated here. We have a scaled down version of this in the UK. It's still in development in the UK, and that's at the Bowlby Underground Laboratory, where we have the Dark Sphere project coming up. And Bowlby is 1,100 meters underground, and it's right. This is kind of like the layout, so it's like a T-shaped lab with like a passageway coming out of it. You can read more about these institutes and these research labs on these websites that I have shown. Now let's switch gears to exoplanets. So exoplanets are any planet outside the solar system so planets outside the solar system, to be fair. Yeah, that's all that exoplanets are. And a lot of exoplanets orbit stars, and there's also a lot of exoplanets that don't orbit stars, that are just drifting through space, like they don't orbit as any star in particular. So I found this schematic or diagram very cool for showing a lot of the potentially habitable exoplanets. That is one of the most hot research topics in astrophysics today. And the current summer research internship that I'm doing is with the Sun, Stars, and Exoplanets group at the University of Birmingham. While my project isn't very astrophysics based, I will share more about it in the next slide, it helps astrophysicists and exoplanet researchers in particular. Here I'd like to make a shout out to Professor Amaury Trio and also to Daniel Sebastian, who is my supervisor for my internship. And they have been wonderful to work with so far. And if you wanted to learn more about Professor Amaury, do check out this website where he talks a bit more about his research, and you can learn more about the School of Physics and Astronomy. Okay, so the project that I'm working on, it analyzes the cloud cover over these telescopes. These 4 telescopes form the Speculos Southern Observatory, and this is located in Chile in South America. So a key part of astronomy is observing the night sky, as expected. And to observe the night sky, you need ideal weather conditions. That means you need to monitor the skies above the telescopes, you need to monitor the cloud cover, the temperature, and if the temperature and cloud cover are something that's unsuitable, or if the weather's bad, the telescopes need to be shut. So you can see that from these black openings that you see, that's the telescope open. So if the weather's bad, they shut the domes. And that is primarily what I'm studying. I'm studying the cloud cover over these telescopes. So these 4 telescopes of Speculos South, they are named after the 4 largest moons of Jupiter: Ganymede, Io, Europa, and Callisto. Now, physics, if you go into physics or astrophysics, astronomy, you will find out that we love coming up with interesting acronyms. Speculos, which I recently found is actually also a sweet treat. I had no idea. So Speculos in astrophysics research actually stands for this project, which is Search for Habitable Planets Eclipsing Ultra-Cool Stars, where the bold and capitalized letters, they match what you have over here. So search for habitable planets eclipsing ultra-cool stars, or searches for potentially habitable exoplanets around the smallest and coolest stars of the solar neighborhood. So I took this quote from the website of the project, so do check it out. It's incredibly cool. And so from this image over here, as you can see, these skies are perfect for viewing. I mean, of course, it's the day, but this is the kind of weather that is ideal for viewing. No clouds, no disturbances, you can view it. So even if the telescope was open during the day, that wouldn't be a problem because there's no rain, there's no clouds. However, we have quite the contrary situation over here. Lots of clouds, and these clouds don't look very friendly either. Especially, I mean, this is on a mountaintop, so if clouds like these come in, it often means that if there's rain, it's gonna it's gonna eventually freeze when it settles down on the telescopes or on the ground because the temperatures are very low. It's very, very cold. So I thought I would show you an animation or a time lapse of what it's like observing using one of the telescopes. So this is using Ganymede, and I think that's camera 1. Thank you, Daniel, for sharing this video. So you can see how, yeah, so you can see that the telescope itself, it rotates with as, yeah, as time goes by and as it goes from day to night. And you can see how the dome position also changes, because if you're observing an object, because the Earth rotates, that object also moves in the night sky. So you want to keep observing that object throughout the night, which is why the telescope has to move with the rotation of the Earth, so it's fixed on that one object. So moving on, I'm going to share a little bit more about what I do with my project so at the moment. So here in this first image, we can see the weather station. The weather station collects information on temperature, humidity, and pressure, and so on, like the data from the surrounding atmosphere around the telescopes. A key thing to remember or note from this is that if the sky temperature as detected by the weather station is above negative 35.5 degrees, it's a bit too warm, and that means that there's a very high chance of clouds forming. And in the first stages of my project, what I did to just identify, images where we had massive cloud cover was to actually look at the temperature data and correspond it to the images and study whether or not there is a significant cloud cover, and they actually matched significantly. So step 1, I extracted a lot of the images of the cloud cover being present, significant cloud cover being present over the telescopes. My next job was to find out similarly clear pictures of the skies. So at this point, I was focusing only on the daytime images, because the nighttime images is a little more tricky to analyze compared to the daytime images. So this is a daytime image, this is a daytime image, and that is a nighttime image. And you can see the Milky Way across the sky. Super pretty. So yeah, so as I completed the first step, which was to, get the images, the second step was to actually build a Python program model for machine learning or artificial intelligence, which would be trained using the cloudy and clear sky images. And then eventually it should be able to output a prediction if I put in any other picture of a cloudy or a clear sky. It should be able to tell me whether the sky is clear or cloudy. So it's a cloud detector. And the main reason that this project is going to be extremely helpful to astronomers using the Speculos telescopes would be it would really help them to be more efficient, and it would also help them, keep their equipment much safer, because if you can figure out what the cloud cover remotely, so we don't always have people on site there because of the extreme situation like weather and temperatures, and I guess accessibility as well. So a lot of the research work and observation is done remotely. The telescopes are operated remotely. So that's one of the goals of this project. If I build a cloud detector successfully, and if it is implemented on site, then then the astronomers will be able to tell fairly quickly whether or not it's a suitable time for observation. So far, I have been able to build a preliminary model which can give me a fairly decent prediction of whether or not it's cloudy or clear. And right now I'm working on on further improving the daytime model for predictions. And within the next couple of weeks, I'll also get to the nighttime images. So in this picture, you can see Europa. I think it's camera 1. And you can see the cloud cover over the telescope is quite clear, so that's good weather, which is why it's open. Yeah, so in my final couple of slides, I thought I'd tell you a little bit more about my involvement with societies at the University of Birmingham. Um, One of the societies I'm very heavily involved with are AstroSoc, the Astronomical Society. Last year I was their outreach officer, and this year I'm the chair for AstroSoc. And we love doing outreach activities. We have loads of outreach activities like Sky This Week, where we give updates on what to observe in the night sky that week. We have World Space Week celebrations, which we started last year. We're going to have more celebrations coming in this year. So do join us and get a chance to, engage in lots of talks, quizzes, and interactives that will really, build on your understanding of the field. Furthermore, if you're interested in learning a little bit more about our talks and outreach events, do check out our YouTube channel, or you could just, on YouTube type UOB AstroSoc and you should be able to find us. And there's lots of talks ranging from topics on exoplanets as well, exoplanets to dark matter and, satellites and so on. So do give that a look when you get the time. The other society I'm really involved with is SatNav, which is our university's biannual student-led science magazine. It's Science and Technology, News and Views, so it's abbreviated to SatNav. And I am the physical sciences editor for SatNav, and it is one of the most rewarding experiences I've ever had. I love writing and outreach. So, and you can see in this picture right here that it was me writing an article for SatNav late at night, and it's really nice when you get to work with a bunch of other science journalists or from university, because you get to learn more about how outreach works in the professional world, and we also print out our magazine. So if you're interested, do check out our online versions of the magazines we hand out. I realized I didn't mention this above picture, so this is actually a screenshot from one of the outreach events that AstroSoc did earlier this year. You can actually see Professor Amori right here, and that's me, and a lot of our committee members and viewers. So this was during our careers night, which we did earlier this year, where we discussed a lot of, what kinds of careers can you get with a degree in astronomy or physics, and it was a very nice panel discussion that we had with PhD students and professors in the field. So, moving on from, university, I am in my third year and I'm going to do my master's next year. So I thought maybe I'd share a little more about what you can do with a physics degree. My plan is to get my master's, PhD, postdoctorate, travel around, do a lot of research work, and also to work in Tanzania at some point. That is one of my top bucket list priorities. I want to go back home to Tanzania someday. And to be fair, with a physics degree, research is not the only thing that you can get into. Physics is a very, very, I would say, versatile degree. On my first week in first year of university, I remember someone told me that physics is the one degree which can get you a job in any field you'd like. Over here, I've just listed a bunch of fields which came to me off the top of my head, where I know for a fact that my friends or colleagues have gone on to work with after getting a physics degree. You can go into research, teaching, education, finance, software engineering, or pretty much anything, to be fair. And if you would like to have a career change after physics is a degree such that it will really benefit you, because in physics you don't just learn science, you learn problem solving skills, you learn how to tackle complex situations in, let's say, the most efficient way possible. Plus, it gives you a lot of a technical understanding of the world around you. You could maybe, I don't know if for instance, you could apply basic logic to fixing a lot of, practical situations around you. So physics is, the only yeah, I mean, I would say you don't have to go into research with physics. It's what I want to do, but a lot of people don't go into research with physics. So give it a go if you're interested. So, to conclude, I would like to say that apply for summer schools. It is a great way for you to gain more experience while in school about and experience new things with, diving deeper into what you want to do. Maybe by the time you apply for university, it will give you a better idea of your interests as a student. So here are three links. I just realized that you might not be able to click these links, so I will find a way to get them to you. And you could also check out my website, link right here, where I add a lot of articles, videos, and photographs. And there's also some quizzes on astronomy, on physics and astronomy. So do give that a look if you're interested. And yeah, I wish you all the very best with everything you do in school and beyond. And I'll hopefully be able to see you sometime in person. Bye bye.